Here is a picture depicting graphs of two functions. One function f of x and the other function g of x. Okay? These functions are exponential functions, and they have the same, what's that arrow represent? That's the doubling displacement that we talked about before. Remember that every time x changes by this much, then the value of each of these functions, the value of f of x should double, the value of g of x should double. However, I'll say that the doubling displacement for these graphs is not necessarily the same as the length of this arrow. You should probably think about determining just what the doubling displacement is for these graphs. You can look at the graphs and see. So, can you identify the common doubling displacement? That is, can you draw an arrow such that, excuse me, whenever x changes in the direction of that arrow by the length of that arrow, y doubles? Okay, in any case, so you should do this. You should identify that displacement and convince yourself that the two graphs appear to have about the same doubling displacement. It'll help you look at the graphs and help you understand what to do here. So, anyhow, the graph of f of x, as you can see, goes through point A. The graph of g of x goes through point B. Now, I'm saying if the y-coordinate of B is double the y-coordinate of A, so we're going to assume the y-coordinate of B is double the y-coordinate of A, and that certainly seems plausible from the picture. Does it follow, then, that the y-coordinate of point D is double the y-coordinate of point C? Now, you should stop for a minute and look at point D and point C. See if in the first place it even looks like that might be the case. And then in the second place, whether it looks like it ought to be or not, given the conditions of the problem, is there a way to show that it has to be so? That the or can you give a reason why it might not be so, despite the fact that maybe it hasn't been drawn completely accurately? Okay, so you should stop and think about this question. Okay, but now the question then is, okay, is g of x equal to 2f of x for all values of x? Okay, now this upside down A means for all. Okay, so the upside down AX means for all x, for all values of x. Can you conclude that for any value of x you might choose the value of f of x, which is, of course, the value of the y value of this point, is 1/2 of the value of g of x, or the value of g of x is double the value of f of x. It might look like it is. Here it might look like it is. I don't know, because it gets hard to draw these graphs accurately when they get really steep. So, can you determine whether that must be true or not based on the properties of the exponential function? Again, that's a pretty challenging question. But it's worth a good bit of thought. I'll give you some hints, maybe even a solution. But you want to think about that question. Okay? Now, there's another question. I've got this point E here. Okay? Now, I've got x-coordinate x sub E. That's the x-coordinate of point E, labeled on the x-axis. And I've got y sub E, the y-coordinate of point E, on the y-axis. Okay, don't confuse the y-coordinate of point E with the point where the graph of f of x intersects the y-axis. They're different the way I've drawn it, and there's no reason to assume that they're the same, so that's irrelevant. Okay, now, we're going to assume that f of xe is less than 10 times ye. Okay, now you want to stop and think about what that means, because you can't understand the problem without understanding the meaning of that. So stop for a minute and see if you can comprehend what is meant by this, because that's a real stumbling block for almost anybody at this point in their education. I'm going to explain it in a minute. Stop and think about it. Okay, you should have stopped and thunk about it. If you didn't, well, you didn't. But you should have. Okay, so this just means what? That if I, what is f of xe? What would f of xe be? What's that represent? Well, that represents the value of this f of x function when x equals x sub e. So we go up here. The f of x function isn't graphed quite that far, but we see if we follow the trend that we're probably going to cross the f of x graph before we get to the top of the board. And I was standing right in front of what I was pointing at, so let me move to the side. Okay, again, f of xe is the value of the function f when x takes this value. Well, what's the value of this function when x takes this value? We just move up here until we hit the graph of f of x. Now, the graph of f of x hasn't been completed to a point right over x sub e, but it seems pretty clear that from the trend, by the time we get to the top of the board, we're going to have crossed the graph. So what I'm saying is now that the point where that occurs has a y-coordinate that's less than 10 times this. Okay, so I go up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that this f of x is going to be, f of xe is going to be less than 10 times this, okay? So, make sure we understand that. That's not a simple thing to understand. It's not a simple thing to understand these conditions. I'm trying to stretch you a little bit with these questions, okay? So, now we want to prove. Now, I've put this in this arcane-looking notation that you are unlikely to have seen, but might have. Okay? This upside-down A is called the universal quantifier. It means for all x. This backwards E is called the existential quantifier. It's a backward E. It means there exists. So there exists a doubling displacement. I originally had an arrow here, and I decided that arrow looked like another symbol. It could be another symbol because it's a standard symbol, so I replaced the arrow with the words doubling displacement. So there exists a doubling displacement, and then this vertical line means such that the graph of h of x intersects the graph of f of x. Now we'll digest that in a minute. I've rewritten that here. Prove that there exists, what? Prove that there exists. So starting right here is there exists a doubling displacement such that the graph of, and then the rest is just the same, the graph of h of x intersects the graph of f of x. And then we continue down here where h of x is an exponential function such that h of x sub e equals y sub e. Now, what's it mean for h of x sub e to equal y sub e for some function h? Well, right here is the point x sub e, y sub e. It means that the graph of h goes through this point. Now, eventually, and you won't learn to do this right away, but you want to think about how this states exactly what I said, how this statement tells you that the graph of h of x goes through this point. Okay, now it can take months, even years, before you get really good at reading this notation and concise mathematical statements. So I'm telling you exactly what the statement says, but think about how this is worded and how this is more concise than most ways of stating what we're stating, which is simply that if f of x above this point is less than 10 times as high as this, then we should be able to prove that there's some doubling displacement, because there is a doubling displacement for the f of x graph. We should be able to prove that there's a doubling displacement such that if h of x is an exponential function with h of xe equal to ye, with that doubling displacement, then the graph of h of x has to cross the graph of f of x. It's a fairly sophisticated statement, fairly sophisticated idea. And I should probably add here, it's implicit, but let's make it explicit. H of x having the said doubling displacement. Now, there are more concise ways to say this, but if I get any more concise, it's going to get even more confusing than it probably already seems. See if you can digest this and do it. Of course, I'm going to follow up with some hints.